Hi, I'm Mike. This is TYT Science. I haven't posted for months, but now I'm back, and today I want to talk to you about open access and open data. Now, the reason is this. There is something of an open science revolution going on. We are fundamentally changing how we operate and how we communicate in science. And some people have called this Science 2.0 or open research, but there are big changes going on, and there are two main halves to this. One is open access, and the other is open data. And you shouldn't confuse the two, even though lots of people do. So let me give you a brief as I can be, summary on what they are and what's going on. Okay, let's start with open access. Open access is simply open access to the results of scientific research, meaning that all the scientific papers produced should be freely available to any scientist or even any member of the public. It should be out there and freely available. What you find at the moment is that that is not the case. If you were to do a Google search on any area of scientific literature that you find interesting, and then you come across a paper and you can see it by title and an abstract short summary about the work done. If you click on that to try and get access to the full paper, you might find that you come up against a paywall, and that means that you have to pay up or go away. You're not getting in at that paper. Now, this shouldn't be the case, especially not for scientists who need these papers in order to build on that research to further their own. And even with the public, this should be available to them, especially when this is publicly funded science. Taxpayers fund it, the results are made available, but then people can't get at it. So what's going on? The problem comes down to the history of science so far. Now, scientific publications have been going since 1665, when scholarly societies started harnessing those printing presses to circulate the letters of the best and brightest around. As the volume of science increased and there were more scientific findings out and about, there were scientific publishing companies set up by individuals who, of course, needed to cover their own costs. How did they do it? Subscription fees to their budding journals. Now, as science got even more industrialized and grew up, and research institutions and universities started doing a higher throughput of different kinds of science, it was the libraries at the universities and the research institutions that started taking on those subscriptions and having libraries of the scholarly journals, so that the researchers in those institutions could go to that library and leaf through the journals of interest to them and stay abreast with the research of the day. But now it has got to the stage whereby there is so much research going on that you cannot keep up with it just by reading your favorite journals. There could be relevant stuff going on that is published in one of the other countless journals out there. And in order to find out what research is relevant, you would usually now go online and do some kind of search on terms of interest in order to identify the papers that are relevant to your work now, which is when you come across these papers that belong to journals that your university has not subscribed to. And why haven't they subscribed to them? Because there are now so many journals out there and they are all demanding subscription fees, and universities can't afford this anymore, especially when those subscription fees are going up, 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 almost in an unchecked way. And some would say, and many do say, that some of these publishing companies are ripping off science because they're demanding exorbitant subscription fees when they're doing very little apart from playing a middleman role. They're not funding the research, they're not doing the actual research, they're not even doing the peer reviewing, because that is done by other scientists within the same field who do it for free. So all the publishing companies are doing are managing the process and making this available and charging huge amounts for it. So this is why people are now saying we need to break the system. One, some of these publishing companies are having a laugh and holding us all to ransom. But secondly, results can no longer be freely made available to everyone, well, everyone within science, by the subscription model, and certainly they can't be made available to a wider audience, stimulating citizen science and all these kind of things. So what are we going to do about it? Now, there are two solutions that are being presented at the moment, and fortunately well, not really fortunately, but anyway, they've been given two color labels, gold and green. Now, the gold solution is this: that you don't fund journals by subscriptions, rather the researchers themselves pay for their papers to be made freely available immediately to everyone for the rest of eternity. The green model is subscription continues, but in order to address the problem of availability, after a period of time, such as 3 months, 6 months, 12 months, the scientists themselves or their research institutions can make the papers available via institution repositories or something like that. Now, different people have different preferences as to what should be the best model, and at the moment you currently have a mix of open access journals whereby you pay up front in order for everything to be available, and subscription-based journals, and journals that are some kind of hybrid of the two, such as a subscription-based journal that will also happily take extra money in order to do the gold publishing and make your particular paper available immediately. So all of this is in flux at the moment, but the important thing is that there's this massive drive on in order to make the results of research widely available. Now, little afterthought, there's something else going on with open access which is important, and that is open access to reuse the results of research, and that is lots of scientists are trying to get together to push publishing companies to allow them to do text mining on all of the publications, and there's been some pushback from publishers for no particularly good reason. I think it's a bit of a dog in the manger attitude, but anyway, the volume of research is so huge that we are actually going to need now to be doing machine reading of what is being published in order to help extract more information out of it to further science. Okay, so that is open access. Open data is slightly different, because with open access, remember I told you that is free access to the results of research. Well, bluntly, frankly, the results of research are papers, and papers, bluntly, frankly, are only what the scientist chooses to publish after having collected all of their data and looked at all their data and decided this yes, this no. And in fact, in some circumstances, scientists don't even publish anything from a research project. I have done research with colleagues on some 4 billion euros worth of projects funded by the European Union, finding that only about half of those projects had any papers out in the literature that were traceable. Granted, it was the larger projects and that were much more likely to have something out there, but nevertheless this 50% figure has come up in other contexts, such as there was a massive study done of lots of scientific presentations and posters and conferences looking to see what proportion of those went on to become full publications. About 50%. And similarly, it's well known that with clinical research trials, a lot of those results get swept under the carpet, in fact up to about 50%. It has been shown in studies. So this in itself is a massive problem, because it means that we collect all of this data, but then because of time constraints and because of what we think will look good for us and what will fly or not, we only publish papers on a selection of those data, which means massive waste and also a distortion of what we're actually finding. Now, the way to fix this is clearly to publish the raw data. If we do not have time nor inclination to publish papers on absolutely everything that we can see in our data, well, at least we should be making that data available for reuse for other people to go and exploit it to its fullest. And furthermore, to check that we have done our work well by doing our analyses again, just to make sure that they're good and solid. That's important. There was a recent paper, actually, a very famous paper published in economics on austerity, and the results of which were taken up by lots of governments around the world. But then when the raw data was actually finally available, a student tried to redo the analyses and found that he didn't get the same results. When it was investigated further, the original researchers had actually not added up a column correctly in Excel, and so had published the wrong information, but this was only corrected via open data. So it is important. And in fact, there have been other studies that showed that for those scientists at the moment that make their data widely available, they are more likely to have highly cited papers, and also their data analysis are more likely to be correct. It's better behavior. But still, knowing all of this, scientists are not rushing in to go and make their raw data available. Why is this? Well, it's quite understandable, really, because there are lots of apprehensions about doing this. For example, if I were to take the raw database I have now from one of my studies and just put it out there, lots of things could happen that I wouldn't be happy about. Someone might go and redo my analyses and show that I'd made lots of screw-ups, like with that economics paper. Or they could do an absolute hatchet job, a pig's ear of the data analysis, and say that my data shows something that it doesn't. And then am I going to get drawn into association with them? Or maybe if I put the data out there, they're just going to be a whole load of students that are going to be pestering me at the time to be working through stuff that I'm trying to work on at the same time. And also, very importantly, for medical data, where you actually have individual patient records, you cannot have patient identifiable data out there. So if you've got that kind of database, you don't want to go into that awkward legal territory without a lot of help. But nevertheless, open data is clearly important for all of the reasons stated before. So what do we need to do in order to make this transition? Well, it requires several things. First of all, it requires mandates from the funders for scientists to actually go and put it out there, to go into that uncomfortable new territory. And this is starting to happen. It was done first really by the National Science Foundation in the States and the National Institutes of Health out there. It has recently been mandated by Research Councils UK, and all of these bodies need to start actually enforcing it. That's another trick. But they also need to be providing a lot of support. Now, there's lots of data repositories starting up out there, independent or associated with institutions, but funders will have the capacity to actually start nominating which ones are good and which ones scientists should be going for, so give them some guidance. And lastly, there needs to be some kind of incentivization for the scientists to do this and do it well, so that the databases out there are actually useful and not just gibberish. And so the model to do this is emerging at the moment and is generally agreed to be as follows. Databases should be citable, like papers. Now, in the scientific literature, papers have unique identifier codes, and so when those papers are cited, referenced by other papers, that citation can be counted. Similarly, if you do that with databases and have a unique place that the database can be found and add a unique code, when those databases are mentioned in papers, again, that mention can be counted so that you've got metrics for usage of people's papers and metrics for usage of people's databases, so you can see what kind of impact they are making. And finally, a very novel invention is the data paper and the data journals. So these are journals being set up now that are looking to publish data papers, and these papers are going to be slightly different from your normal scientific paper. They're more like how-to manuals associated with the database. So what they will do is they will talk about how all the data were collected, they will list what all the variables are and how to interpret them. So essentially you can read a data paper, then pick up the database and go and use it and understand it fully and work with it and publish on it without having to bother the original researchers. So that's the idea. This is all very new. We'll have to see how it takes off, but lots of people agree that this is the necessary future with regard to open data. And also, open access is currently in a big transition period. Lots of people are looking at the economics of it, and lots of people are testing out different models. So there's lots in flux at the moment, and but nevertheless, it is something of an open science revolution that is happening at the moment. So watch this space. That was as short a summary as I could do. I hope you enjoyed it. Obviously, it's quite a complex area. If you do have any questions, please do feel free to put them in the comments below, and I'll do my best to address them.